Hi, this is Min Chong. We are recording molecular simulation in engineering. So, in this lecture, I want to teach you something new. Probably the earlier lectures, you have already learned how to download an open source software. You know how to compile and how to install in your computer, how to run the simulation, right? And I also told you how to visualize your data, how to visualize your simulations to get some meaningful information. So the point here is that most of the time, and when we run simulation in the future, if you work in a lab doing research in school, like graduate school, or in a company, most of the time, even you're not using commercial software, you're using open source software, you don't write the codes from the beginning, okay? Unless you're sort of computer engineering, but most of the time, if your major is not in computer science, you need to use some people others code, and you use their program, you make modifications. So the topic for today is to modify source code. This is what we're going to do today in this lecture. All right. So we are still using the previous software called DL Method, just to be consistent, because this is written in Fortran, which I'm familiar with, and also the code is it's not huge, right? So probably hundreds of lines that you can read. You can find out what parameter you use. All right, so we're going to use the DMS or DPD simulation. And if you remember previously, if you run the simulation, you will get a thing called history. This is a binary trajectory. All right, and then we're going to use the utility to convert the trajectory to VTF file, and then we use VMD to visualize the VTF file, right? That's what we have done before. Okay, but the second part of this lecture is really about how to look into the source code of the trajectory conversion. We're going to rewrite the codes to add a function that generate a trajectory in XYZ format. So first, we need to review the previous one. Okay, so DPD simulation, how to run simulation. Let's go through that again, shall we? So this is my terminal. You should have yours. And I actually download the latest version, and before I remember we used DMS already. It doesn't matter, it's all the same. But here I need to compile the program, which I need to remove all the the system file during the previous compilation, and I'm going to copy the make file, which is I'm going to use MPI here. All right, and going to add this make file to compile to install the program. Okay, this is what we need to do here. And before that, we need to know whether we have everything we need for installing the program. So the program will actually, let's go back to look at. So the program use MPI for this tool to install this program, and see whether we have that. MPI for it, we do not have that, and see there's instructions. We don't have MPI4, so we need to install with this command. All right, So as I know what is this, I just go ahead and install OpenMPI, MPI, Bing, and which you also need to install library OpenMPI. This, all right, and need to respond to the program and install everything we need, which may take a while. Okay then, so now OpenMPI is installed. I should have this MPI Fort, right? Yes. So there's no input file, of course. And I want to make sure that we have G4chan installed too. So G4chan, okay, we do have that. And then we just need to make -f, make file MPI. This is all we need to do. And then, okay, we don't have Mac too. So Mac is something that can install a program file from Makefile. So let me explain what is this, okay? Because you may not familiar with. So this folder contains a lot of computer programs, and it's usually differentiated by the file extension, the word after this dot, okay, after this period. Like here, this is F90, means this is in Fortran 90, this language. If it is in Python, then it'll be .py, all right? And if it's C++, maybe it's .cc, I don't remember. But each file contains a lot of program. Let me open one for you. Okay, just the smallest one, all right? So as you know, this is a program we tried that before actually in the earlier lecture, but this is so huge. This is so huge. If you go through that, you don't understand what's this, so many variable, right? But it's fine. It's fine. You use the software before. You don't need to know each details of this the coding. But what we need to know is this is everything to running the program, and Makefile is the file that will wrap up all this file into one executable. Okay, so let's go back to look at this again. So all the files will be wrapped up by this MPI Fort and it goes to this dpd.exe. Okay, so this is all we need to do. We just make we need to install this make. Okay, make install make. All right, then let's type the command make -f make file MPI. All right, so I should have this dpd.exe generate somewhere here. Here is the executable. We used that before, right? And then let me do this. I'm going to save all the executable in one place, all right, just to make things easier. So in a previous folder, I just create a file called exe. I'm going to copy the executable I just generated to this folder. And also I want to install the utility we're going to use later, all right? So let's go back to utility. And then again, I'm going to remove the thing from previous compilations. And then I'm going to do the fresh install here. Yep. Oh, I don't have C. I don't have something. I don't have GCC here. So again, I'm going to install GCC, install G++. Okay then, and again, I'm going to make all these files. and I'm going to copy this exe file to exe. All right, and also the second text for this lecture is going to modify this. Going to modify this code. So this is generated from, remember this. All right, so going to copy this too. We're going to copy this traject select BTF if90 to this folder again. All right, so let's go make a simulation. All right, and let's do, let me see, mixture small first. Mixture small, and then I'm going to remove everything we don't need here. Corel output, the snapshot. All right, and then going to, so okay, this is so good. This is so good, but I'm going to change the name of this species just to make it easier to deal with. So I'm going to copy the mixture small to another folder called, let's call it bulk. All right, bulk, and I'm going to move this bulk to the previous folder just to be with our exe here. All right, this has all the executable I need. This is the file I'm going to run. I'm going to change this a little bit. Going to only change to, how about 2 species like before. Let's say WNO, or actually let's do okay, and each one, let's say, how about this number? And I'll have three interactions. So the first one is WW, which is 25 and 4.5. You don't need to know the details of this number because this is about the theory of this method. You just need to repeat what I have done here, okay? This is a simple simulations. And then going to change this control file too. Let's change it to 10 by 10 by 10 with a cutoff here. And I'm going to run, say, 10,000. 10,000 is good. And don't need to equilibrate, or just 1,000. Wait, you know what? I don't need to equilibrate. So from the first one, I'm going to record a trajectory each, how about just each 1,000? So I have only 10 frames to deal with. I only have 10 frames to deal with, all right? So, voila. So I'm going to copy the previous folder called dpd.exe here. And I'm going to run the simulation. And it'll be different than the simulation command before, because here we use the MPI version, which can run it faster. So what you do is you use a command called no-hop minus MPI run minus MP, how many CPU you're going to use for this simulation. So we're going to put it 4, all right? 4 is fine. And dpd.exe, and there is a end sign. All right, we can take a peek at the output file. See, okay, voila, it's finished. It's so fast. All right, so we have this history file generated here, and we are going to convert it using a thing called traject s here. So traject s, and you can type a -h to see the help here, which we're going to use this -s to be more powerful. You can select a certain article particles to output, and also can sort this particle in the right order. So we just need to minus s and see, okay, you have two type of bees, right? And then which bee species you want to type, you want to output. And for now, we're going to use only say O beads. All right, we need to only O beads because this is for the reason we're going to make the bee number not equals 3000. All right, so bee species. So go bee species. I'm going to use number 2, which is the O, add it and finish this 0. And then the first step is 1, 11, okay. And I will have this VTF file generated. All right, so that's the step 1. We'll stop here.